Hello? Hello? Okay. So let's just give just a few minutes for others to join us. Then we start. I hope everybody can hear me. Just a few minutes. So today we are on the part 4 of our Sagemaker Saturdays, and the day 4, sorry, part 1, day 4. So remember, day 1 we scraped the data. Day 2 we did some feature exploratory data analysis. Day 3 we did some feature engineering, and then today we want to finally deploy our model. So that was really an end-to-end. So if you haven't looked at that before, you can go back and you look at the other days that we've done this before. So it's really exciting to take a project from zero right up till deployment. So it's not really too deep into details like it's really the real world is supposed to be, but then you get a feel of how the complete cycle of machine learning projects look like. So let me just go on. So let me go out from here. Okay, so here is our Sagemaker Studio Lab. Let's go back there. This is where we have been working. So last, I stayed back and I did some couple of things, like I'm doing feature engineering on the test data set. We only did it on the train data set. So let's go back and start our runtime. This is what we have been using throughout to do our project from the beginning, the Sagemaker Studio Lab. So I'm going to sign in. So if you have not yet had your own account, you can also request for it. Or again, remember, you can use Google Colab or Jupyter Online or your Anaconda. So it's loading now. Good. So let's open the project. So I'll just go through. Remember, again, this is the land we are the website we are trying to scrape price of land from. So this is an example of the cleaning that we had to do. The price of land here is higher than that's if you check here, they've multiplied. If we divide this price by 500, the meter square will actually get the price per meter square. So this is an example of the cleaning that we did. So what we actually scraped was to scrape these prices, we scrape the location, then we also scrape the meter square, and then when we are also cleaning, we remove these things like this because this is a whole city. Meanwhile, in reality, this is the neighborhood in the city. So another development would be using some natural language programming to get out this information from here instead of getting it out from here. So it's really unstructured data. So now when we look at here, let me keep waiting. So when we look at here, I'll just go through what we've done so far, then we go to deployment. So number one, we scrape the data from the website. That website I just showed you, this website. And when we scrape the data from that website, all this day one, this is what we got, like the final output, this land price data.csv. So which is this land price data.csv? This is it here. So we got this. Every location has the price per meter square and the area, total area. So we got all of these. We got all of these. So now day two, we did the exploratory data analysis to try to find out what are some of the distribution of the data, what are some of the issues with the data, missing values. So we did all of that. We found some irregularities, which the next step was to do now the feature engineering, which was to correct those irregularities. So this is what we did. We corrected the irregularities, So now the next thing now that we are trying to do now is to be able to deploy now the model so that we can have it on Sagemaker. So remember, it's a project I've already done, and I put the link of the project here. and also so we want to do this today to deploy to the model to Sagemaker. So we have to go now to Sagemaker itself. So we will leave from here from the studio. Let's go to Sagemaker, and I think I'm already logged in here, and I'll just go straight to look for let me just go straight to Amazon Sagemaker. So normally you log in, you go to your Sagemaker here, you click here. So now you've clicked there. So this is actually this is the live system. This is the production system. The Amazon SageMaker itself, you see there's a difference between the SageMaker Studio Lab, which was mostly for you to just do some tests, do some prototypes, run some trials. Then now when you really want to deploy, you come now to the AWS, this SageMaker here, standard SageMaker. And remember, this one is going to cost us a bit, but it's not even up to $1 what we are going to do today. Just I think 0.1 or 0.2, 0.02 or 0.01. So it's not expensive, but now we'll be having the advantage of working with all the other services that AWS has to offer. We'll be able to access the S3, able to access lots of services with this Lambda, lots of services when we are now on the live system. So after doing your test here, doing your prototype here, this is why SageMaker Studio Lab was a very interesting offer. After doing all of these at no cost, now you want to go live to scale, you come here. So we will now go here. So SageMaker Studio is something we will look at later, but for now we'll come here. So ground truth is where you can label your data. Then you have the processing to look at the jobs that are processing. You can look at the training. You can do your inference here, pipelines. So edge, deploy your models on edge devices, and then you also have the marketplace where you can buy your models that have already been made. So let's go on here. What we are going to do here is go to notebook. Now we go to notebook instance because we want to create a notebook instance. So I had created one earlier. Let me just delete this action, delete, and let's start and let's do it from scratch together so that you can see. So now I'll go here. It's deleting. So let's all start from scratch. Okay. So it will take a couple of some time for it to delete, and then while it's deleting, again I say we have gone through all these steps: scraping, exploratory data analysis, feature engineering, and now we are trying to deploy. So let's see how it's going there. So one other thing that was really interesting again in this data is because, as I said, many people were entering this data, like entering the price here, like the total sales value. So normally this should have been divided by 500 because this price is really too high, and that's where some domain knowledge helps us to know what are some things that look realistic or what are not realistic, and also helps us to clean our data. So let's check. Is it still deleting? Okay, so it's still deleting. So while it's deleting, so you have here, for example, lots of interesting things in SageMaker, like lifecycle configuration. So which means that if you have, for example, loaded some packages like maybe Numpy, Pandas, and you don't want that each time you start your model, you launch your notebook, it would still take a few seconds to install them again. So what you can do is that you can use the lifecycle configuration to set that so that it already has stored that for you. So, and now, okay, we have it's deleted now. So let us start from zero, how to launch a notebook instance, deploy our model. So you would see it's very, very simple. We've done the biggest work from scraping, exploratory data analysis, feature engineering, and now it's just to create the notebook instance and deploy our model in the cloud. So I'm going to go to create notebook, and then we are going to give it a name. let's give it a name, land price app. Land price app. Now from land price app, there are the main things when you're creating, when you're deploying on SageMaker. There are mainly four things. Number one is you always have to choose the bucket that you would store your training data. Then that the model would take the training data from and work on. So you need to choose which bucket is your input source. You need to choose where would you store the final model after it has been trained, and you need to choose where would the model come from. That is from the ECR. Where is the container that you would use to get the model image from and bring it and do the training. And then also you need to choose the instance type. Which instance do you want? So for now, we would not we'll just leave it at this. It's a small, very small project, and we'll just leave this default. You could go for more depending on the nature of your project. So let's just go down here, and then the next thing now is we have to choose give it a role, an IAM role, because it needs to access the S3 bucket, the SageMaker, to be able to get the data from, train the data, and then also store the model artifacts that we can use even later. So let us go here, click here, and then we go up here to create new role. So normally you could decide to take a specific S3 bucket, maybe a bucket that you've already created, and then you say it's only this bucket that the SageMaker could access. It can't access any other bucket. But for now, we'll just leave it at any bucket, and then we just create the role. So now the role has been created, and we can now go ahead. There are other changes here, but we will just leave them at that. You could put some encryption keys, some KMS, so that you have some security here in your data. But then we'll not go into that for now. Then you have other network settings you can do, Git repositories. We'll just go ahead and create a notebook instance, and I know it's going to take a couple of minutes for the server to spin all the servers behind, so that we can have our notebook and we access it like just almost like we were here on our SageMaker here, the SageMaker Studio Lab. Just this kind of notebook is what we are trying to access. So it's spinning them up, it's setting up everything at the back. So serverless, we are not doing anything, we are not touching anything. It's just doing all the job. Then soon it will be ready here, and once this is ready, we are going to open it up, and now we start running our code to deploy the model that we've taken all this past 3 weeks to gradually build together. So here it is taking some time to load. So let me go here and show you the GitHub. So in the GitHub, I've created this Sagemaker Saturdays YouTube. So if I click there, you would see that there is this land price app which we are building for our part 1. So part 2 will be going on to other things. And now here, if we come inside here, I have uploaded the things that we've been doing, like the land price scraper. So we were scraping. I was scraping here last time. So this is here. You can look at this, and as you're following the video, you can go along with me. And then we also have the EDA. As you're watching, as we did in the week 2, this is the EDA we did. So you can follow through, and you can have a copy, and you can continue your training. Then we also have the feature engineering number 3 here, so which is also what we did. So we can also follow that up, and we go through. Then now we also want now to get into our model deployment, which is what we'll be running today. So let's go and check. It's still pending, because the whole idea would be I'm going to copy this whole repository into the Sagemaker here so that we can be able to access all these that we've done and run it from here. So it normally takes a couple of minutes to spin up this the new notebook for you. So while waiting, again, this is just part one. So we are hoping that subsequently in other parts we can go into other flexible things that SageMaker can do, like being able to use custom models like TensorFlow, or being able to bring your own Docker image, bring your own model here. So we will see that SageMaker has lots that it can offer. And you could also have done this maybe with purely AWS services, like using some Lambda to trigger the scraping, so there are lots of exciting things that we would be having here. So we just stay on. Let's make sure we know, okay, we are working on our Saturdays and we are keeping on with our learning of the cloud and machine learning. So while it is loading here, let's just wait. It takes some time to set up those servers, but then you have seen that the simple thing to do, you just go to your Amazon SageMaker, go to notebook, click on notebook instance, and then you just create a new notebook, give it a name. After giving it a name, you select the instance type. Select the instance type, and then from the instance type now, you just give it the permission to access the bucket. So here we gave it any bucket. So if we did not type anything, by default SageMaker has some natural language programming intelligence. It searches and identifies any bucket name with the name SageMaker in it, and it will just go and use it. So that's another tip too. So if you have many buckets and a bucket is named SageMaker something, if you don't give it the right to access the bucket, it's going to go straight and pick the bucket that has the name SageMaker in it. So for now, we just gave it any bucket. So, and if we go, I'll just open S3. Let's see if we have any bucket so far, because we should not have any bucket. Let me even open it in another. It's better to open it in another. Let me go back. So I'll open it in here so that we are checking, do we have any bucket? So we would let's go here and see. So let's go here. So I'll just go back. Let me go back here. So let's go and check if we have any bucket here. So we go to create bucket. So if we come here, so we can see that we don't have any bucket yet, and at the end we are going to use our notebook to be able to create our bucket. Okay, good. So it's open now. It's open now. So let's open Jupyter Lab. So now we are opening Jupyter Lab. Everything has been set for us to start. So let's go now. Opening our Jupyter Lab. So just let's see, it's opening, loading. So when we do that, we'll just copy this whole repository and bring it here and work easily from there. So it's really amazing, it's really interesting. So I'll say keep waiting while it's loading. So good. So now what we want to do now is, first I want to go here, we'll click here, then we clone a repository. So remember, we click here to clone a repository. So it's asking now for the link of the repository. So what do? We go now here. It's our SageMaker YouTube Saturdays YouTube repository. I'm going to copy it. Right click, copy. Then I'm going to bring it back here. Sorry, here. I'm going to bring it back here. Then I right click, Control V, I paste. Then something very important to do, don't forget, is that you put .git at the end. .git at the end. So when we put .git like that, we clone. So now we have it here. You see our Sagemaker, very fast. Sagemaker Saturdays YouTube is already there. So if we click on it now, we go into our land price app, our first project. So you see, we see already that we have the price scraper here, the the exploratory data analysis, the feature engineering, and then now it's a deploy that we want. So remember, we've already done this in previous days, and then this is the data we got when we scraped the data. This is the train clean data that we did last week, and then I also stayed back and did the test clean the test data, because the things you do on the train data, you have to do them also on the test data, remember. So let us go ahead now, and then we are going to run now this to deploy our model. So remember, this is a project I've done before, so we are trying to walk you through. So I'm selecting a kernel here. You see there are many options. You could have your PyTorch, you could have TensorFlow with Python 3, have TensorFlow Python 2, so you could have R. So there are really lots of options here. So what we need here is we are going to go with the Conda Python 3. So we are going to click on Python 3, we select here. So now let's go down. So this was the problem statement that I wrote for the original project, which we are like rebuilding together. So we've already done these steps. We've scraped the data, we've done exploratory data analysis, we've done feature engineering, and then we are now trying now to deploy the model in SageMaker. So we are going to be using XGBoost. Remember, XGBoost has won many competitions. It's very powerful, and it's really good because we have those outliers. So a linear model will not be very good, because we noticed from our exploratory data analysis that we had so many outliers. So the first thing to do is that we are going to import the necessary libraries, and then we are going to bring in the train and test data. Then we are going to build our XGBoost model, the inbuilt XGBoost model, bring the container. So we are going to call and call the image from the ECR, and then build the model, train it on our data, and then we deploy it and create an endpoint. So also we are going to do some small tests of the predictions, just to show you how you can test your model. So let's just go so you get the feel of how to deploy your first model if it's your first time, and you see how it works. So here we are importing SageMaker, importing the Boto tree, which is important to be able to communicate with resources in SageMaker like your S3 bucket. Then now we are also trying to import how this is what will help us to get the image from the ECR, the XGBoost image, because the models are stored like images, so that we can call the image, then reconstruct it and run it on our data. So now we are going to be able to retrieve, still helping us to bring the image, and then this is also to help us to create a session, like a login session. So we know, okay, this is the user, like me, I'm currently logged in and I'm doing this task. So that's what we are importing. So let me click on that. So most of these steps are standard. So as soon as you get the principle right, you can go ahead to deploy many models. So now we are trying to give a bucket name called land price app. So now if I run this, now I say this is the region. So if I run this and I print, it's US East 1. So this is the region that I am in, and I also like to create a bucket name like this. So if we go here and we say we are trying now to get into this resource S3, and then now here we are saying if my region is US East, which is my current region, create a bucket, and then you give it this bucket name, this name here, this bucket name here, this land price app, and then now you print now that this S3 bucket has been successfully created. So let's run that and see. We run it, so we see, that's why we say we got it here, that S3 bucket has been successfully created. So you want to see that, let's go back to our S3, and then we refresh this page. Remember, there was nothing there. We refresh that page, and then now what do we see? We see that we have a new bucket that has been created. So you see, just with that line, so let me put this back here. So just with that line, we were able to create, close one of these. So we're able to create our S3 bucket. So that's fine. Means everything is working well. The bucket has been successfully created. So now we want now to create another subfolder in that bucket, which is going to be called XGBoost inbuilt algo, so that we can be able to keep our XGBoost algorithm inside this bucket. So now we say, what is the output? The output is the S3 bucket, and then we always use this like this, and then we are going to put in the bucket name here, and then we are going to put in this prefix. So it will be like go into S3 bucket, open the folder called the land price app, which is the bucket name. Then inside the land price app, open this other folder called XGBoost inbuilt algo, and then that should be the output part. So this is it down here. This is it down here. Land price, XGBoost inbuilt algo, and then the output. So now let's move on then. So here we now want to bring in our data set so that we can put it in our S3 bucket. Remember, one of the conditions I said was that the data has to be in S3 for Sagemaker to collect it from there. So let's bring in our Pandas, PD, bring in our Numpy, and then this URL lib is because I'll be using a link directly here to get the data from the GitHub. So I'm just linking directly to the data there. So which means that I'll come here, click here, go to, I want to bring, say, the train clean data. I'll click on the train clean data. Now when I click on the train clean data, it's opening up. Then I'll go now to raw. Remember to go to raw, because watch this, look at this URL. When I go to raw, now this is where I get now the full path to get to this CSV file. So this is what we're actually going to copy here, and we are like scraping our own GitHub page to get the data in. So that is what we get here. So for the train data, this is what we are getting here. We are going there to scrape it. So let's paste it here. Let's paste it here. So that is what we are actually doing. We are going there to scrape that data, and then we call it the name train-clean.csv. So that's why we are using the URL lib here. That's why we're using this URL lib. So the URL lib, you send a request to retrieve this URL, retrieve information from this URL, and this is the URL we just pasted here, so that we can give it now the name train clean CSV, and then now it's going to print us a log, successfully downloaded the train clean CSV file, or if there's an error, it's going to give us an error, and then now also we would also be able to say this is the, put it in now like a data frame. So pandas pd.read CSV as a data frame. So we store it as data frame pandas so that we can be able to view it later down there, or manipulate it if there's need. So now we run this. Okay, they say URL lib is not defined, so it's because PD is not defined, because I did not run this line previously. So I have to run this line so that we can import the pandas and also import the URL lib. So I run this first before running this. So when I do that now, you see it's now says downloaded train clean CSV. So it's good now. Now we are going to import the test data set. So again, remember, we are going to go back here, go here, look for the test. Let me go back out again, look for the test cleaned, go to raw so that we actually get the raw like this, don't forget, then copy it. Why am I not able to copy this? Copy it, Control C, and now we take it here to the test. So we replace this. I mean, you see how we got to that. So I'm going to put it here. Let me reduce this slightly. So we are going to paste this here, go here, paste, Control V. So we have the test clean, and then we run this. So you see we got it right. Downloaded train clean CSV, data loaded its data frame. Good. So now let us check to see the shape. Shape is 554. Let us check to see the shape of the test of the train. 2216. Okay, small data set, but then we will just use it to be able to understand the process, how it goes. So we can also take a look at the head. We see that we have our area, our price log, which is what we did last week, and then we have all the different one hot encoded popular neighborhoods. So here also we have the same thing, all the one hot encoded popular neighborhoods. It looks good. So now let us now save our data now, so that we can be able to access it later now with our Sagemaker. So this whole code, we are importing OS, which would help us to navigate the folders easily. So we are doing pd.concat. So we are actually, and what is important to note here is that the XGBoost inbuilt model needs the first column to be your dependent variable. So that's why we are putting price log here, and then we're concatenating the rest. So we are like kind of like shifting, taking the shifting and making sure that first, what comes first is the price log column. This column, this is how this the format is just like that. You just have to master it like that. For your XGBoost model to work, this column, this price log column, price log must be the first. Then the rest can come in any order. That is what we are actually doing here. We are saying pd.concatenate, take this first price log here as the first column, add it to every other column except the price log column itself, which we drop because it's already here. No need for it to be twice. So that's just what we are doing. Axis equals to 1. So that's on the columns. And then now we also want to convert it now to CSV. And then we're calling it now train CSV. We take off the index, all these index here, 1, 2, 3, 4, index is false, and then we take off the headers, no headers. So again, XGBoost doesn't want headers. XGBoost wants your dependent variable to be the first column. So remember that it's very, very important. Now we are going to create now a session, and then we are going to be able to join all of this, put this now into the train test, so that we can upload this file. So if we run this, all of this is just that we are now putting it now into the bucket. So same here, the test data, you put the price log as the first column, the rest can follow in any order. Then you dot join, use your os path dot join with the prefix. So you add it to upload the test file here, and then so that now if I run this, let's go to our S3 bucket and see what we've done. So if we run this, let me refresh. If I refresh it, I refresh, I go to S3 bucket. This is what we see here. There is the XGBoost inbuilt algorithm, and then now inside now we have the train, which has the train CSV inside. Then we have the test, which has the test CSV inside. So perfect. So that looks good. Let me take this back here. I'll just close this other one. So that's what we've done now. So that was the main condition for you to be able to run your model. So your model now will be able to go and pick up from that bucket. So now we already can go ahead. So let us build and train the inbuilt XGBoost model. So we are going to create build our container. So we're trying to retrieve now the XGBoost model. so that it comes to us for use. So let's do that. So now that's okay. Now let us initialize our hyperparameters. So let us see. I'm just using some parameters here, but I think this one is much. We need to go to, let's do something like 5. So then again, this is also another area where we need to try to do some training, understand all these hyperparameters, especially XGBoost has lots of parameters. So we'll just run it here so that you see how it is done. But then there is also auto tuning that can be done in Sagemaker here. And or you could also go back to your here, run some hyperparameter like a file like this, do some run some hyperparameters, and then come up with some optimal value. But then I'm just showing you how it goes. It's not really the most accurate. It's really an iterative process. You have to go forth, back and forth, make sure we have the right values for the optimal results. So let's go ahead then. I'll just run those with those, so you know that next time you have to take some time to maximize the parameters, the hyperparameters here. These are very important. This is what really drives this model, the XGBoost model. So let's do that. Let's just use this. Then let us go here. So we are now actually building the estimator. So the estimator is, we are saying that what is the image? It is that container. It's this container here. So we've called the XGBoost to come. So where our hyperparameter settings, these are them. These are our hyperparameter settings. Then I say again, this is a whole task that you can spend a whole time doing to find the right hyperparameters is key. Now we are saying that the role, so we have now the Sagemaker role that we gave so we can access the S3. We already gave it the permission. Now how many instances do we want? We just want one instance here. Then now we have to specify the instance type. So this we are going to use this this ML M5 2x large, and then now we decide the volume size, give it 5 giga, and then the output path, where would the model be? Remember, we define our output path up there, so it should go in that path. Then now we want to use spot instance. This is very important because this is what is going to make it to be cheaper. So if, for example, you remember if you understand, there is the on-demand, there is the reserve instance, then spot instance. So you can try to review those pricing, but spot instance gives you the cheapest rate. Just you look they look for opportunities where capacity is down, then Amazon will let your process run. So since we are not really running any critical real-time production, we just can use our spot instances, but in real life we will normally not be using a spot instance. This is just for demonstration, so remember that. So now we want to get a maximum run of 300 and a maximum weight of 600. So let's do that. Let's run that. When we run that now, we can also come now and then we do our estimator.fit. So now we want to fit now this our estimator now into that we are now, this is the train data, which is our train that we did, and then X input the train. Then now we want to validate it now against the test data. So this is cross validation, so that we are able to get good parameters for our model. So if you don't understand that, you need to try to revise the concept. We always need to do some cross. If not, there will be overfitting because the model will only be so used to the train and will not be able to do well on this test. So we have to try to see that. So let us run that. And good. So now we're actually training the model. So this is actually training the model. So if you see here, it says it's starting the training job. So it is now going now to go and get the image, the container, the image of the XGBoost from ECR, Elastic Container Registry, and bring it here so that we can now be able to use that stage XGBoost and then build our model artifacts and store in our so you see it's launching the request, trying to get the image so that it can be able to bring the image. Let's build our model, store our model artifacts in our S3. and then in our output part, as we specify, store it there, and then from there now we can be using it to make predictions on seen data. So once it has built the model, okay, fine, you build it and it stays there. So, and then maybe later you can be doing some model retraining. Maybe after every month you should scrape and run and build and test, or you put your cloud watch to watch if there are any poor performance below a certain threshold. It should trigger some action. But then those are things that yeah, they are advanced things that you do. But for now, we are trying to see the process. There's a lot that goes on after launch, hosting the model. So let's see how it goes first. Then we can get into later more complicated things later on. So now it is going on to bring in the image. So it's taking some time because it's trying to go to ECR, download the image, bring it to us. Then later on you use the image to train on the train set, use the test set like for validation to validate, and then you'll be adjusting as per the performance, and then at the end now we'll get a trained model. So it is preparing the instance for training. It's preparing the instance now to start training. So soon you would see the training will start, and the error, you'll be able to see the error, because here we are going to use the root mean square error. Remember, this is a regression problem. So say it was classification, you'll be using other things, accuracy, F1, recall, precision, all the other things. But then here, what we are going to be using here would be the root mean square to be able to get the. So if you see now, what is it doing? It's downloading the input data. So now it is collecting the data from our S3 bucket so that it can now use it now to build the prediction. So that is actually what it's doing. So soon it's going to get it from the S3. So it is also downloading the training image. So yeah, we talked about it, bringing the image so that the XGBoost image can be brought in, and you'll be used now to do all this training. So you're not doing anything, it's doing it for you. So now let's see. So if you see here, we can look at the results. So if you see, it started. Let's go down, let's go down, let's go down, let's go down, let's go down. So if you see here, we have something like 0.84 and 0.9. So this is an example of overfitting. Even though the gap is not too wide, but it could be wide. I mean, yeah, you cannot really have exact. So it is performing very well on the train set. So the error is very low. Whereas on the test set, it is slightly higher, 0.9. So this is an example of overfitting, where it is so good here, and then here is having a bit more errors. So anyway, we could go back to the hyperparameters tuning again to be able to retune so that it becomes better. But for now, we'll just go on, and that I can leave it to you to continue to learn other skills. So we are going to deploy now the model. We're going to create an endpoint. So also one thing to see before we go here is that notice that the error has been decreasing. So let me just come up here. Let's just pick anyone. It started with a huge error of 7.6 here, 7.7 here. You see it goes down to 5.8. This one goes to 5.8. It goes down to 4.4. So you see it has been improving. So that's the whole training. That's the whole machine learning. So it is building, it is training and adapting, correcting errors, training. So now it is here 0.91, 0.87. It is improving. This one is decreasing. It's decreasing. So it keeps going, keeps going, keeps trying. So you see at the end of the day it ends here. So this is how we got here. So let's move on then. And then also this our spot instance now helped us do this saving of 55%. So normally this is what was supposed to be built, but we used our spot instance to get these savings, so which is good. So now let us run our deploy our model. So we're building now our endpoint. So from this endpoint now we can any data can be, we can inference our data easily, either using batch mode, or we can even use our inference pipelines to be able to access the model that we've already built, and then be able to see that and get predictions from that model. So you see, if we go to our S3, go to our land price app. So let us go here. Let me refresh our S3 again. Refresh our S3. Let's go there. So okay, I'm instead on Amazon SageMaker. Let me go back to our. Let me go and refresh our S3. Let me go on S3. I hope this is the S3. Okay, I'll just search for S3 here. So S3. So if I click here, go inside our XGBoost. So this is our output. So if we click here, we have our output. So you see we have our model there. So we've created it. So everything is good. See, we have our model already created. So let's check to see if our is still building the endpoint. So it's from this endpoint now that we should be able to make predictions for our model. So that it's building the endpoint, and then now you can see here, you go here, let us see. So if you see here, you check. So you see, if you see here, we built our model, so it was completed. This is how it got completed here. You can check. So these are, you can be able to go there and look at some things that are doing that they are doing already. So if we go here, we look at our, this is this endpoint I had. So if you go, you can see here. So let's go back here. We see that it's still loading. So you can always go check. So there's really lots of services, lots of things that SageMaker has to offer. So let's go back here and see. Okay, good. So now our model has been deployed. So we can now try to test our data on this model and see what we are going to get. So we are going now to import this so that we can be able to create a serializer. So we are going to take our test data and drop the price log so that we don't have it. This is what we'll be using to check instead if the model is doing well or not. So we need to drop it so that the model doesn't know the answer. Then when we do that now, we are also going to use now, and we are going to predict now, and then we decode it to UTF-8 so that we are going to form a string of it, and then all of that is just to have a series. So when we run that now, if we run this, we want to see the first 10. So if we look at the first 10 here, we'll see that this is the prediction that we have from the model. So we can also run the test clean here and see what we have. So if you see like the first one here, so the first one is low. You see we have 10 here, we have 0.4. So you see that's an example of an error that we have here. So let me go here and let's see something. So we see that we have it's in Yasa, and then instead of it having 10, we had something like 0.4, while the other one, instead of having 11, we have 10, having 12, we have that. So here is 11. So you see already that the model is having some errors as problems with accuracy. So we should be able to run that, and then we should be able to go back to our hyperparameter tuning. So you see there's some price here that is 2. So these are some cleaning that we need to do. Maybe when we divided some of those prices, they went so low, or the data entry was so poor, so we need to go back. There are many things that can go wrong. Then here is 70,000 while it's 47,000. Here is 225 while it's 100. Here is 60 while it's 75. So you see the accuracy we have a problem. So it's because the real data is really messy. So we need to really go back there and do a lot of cleaning. Either we are able to take some time and do some ground truth labeling and correct all those mistakes, because there's lots of confusion there. And also we also have prices that are so varying. Maybe people put high prices and then maybe negotiate later and sell them lower. So there's really a lot here. And then of course, when we do that now, we have to finish up by deleting our endpoints. And then if you see here, congratulations, you've built an end-to-end machine learning app. So it's really has been 4 weeks of from the scraping right till the deployment. It's really been a huge task. So now we can say that, okay, if the accuracy is low, so because the price per meter square was poorly entered by some sales agent on Jumia website, which is what we have noticed already. And then we looked at some, there can still be some farmlands inside mixing up some of these things. And then we also see that the prices vary a lot. People put prices, too many, the same neighborhood has prices really varying. So maybe we could go by the median of the prices, and then we could really try to identify those farmlands. And then you could have a staff who try to correct the wrong prices so that it is really clean if you really want the app to be accurate. So there's really a lot of room for improvement. And this is why machine learning is very interesting. Data science is interesting because it's an iterative process. So we have to go back to the feature engineering and try to see how to clean again, so that we can come back again to the deployment. And you see it's a whole cycle, and that is where you have your CI/CD pipelines, because you always have to continuously improve your model. You need to continuously integrate, continuously deploy, continuously um, develop. So this is we have come to the end of this. So I hope you enjoyed the whole session, from the scraping of the data to the ATA to the feature engineering, and then now the deployment. So it was an end-to-end. It's an example of an end-to-end project. There is really a lot of things that can be done after this. There's really a lot, but then you should be able to understand that this is how the process goes through. So we'll continue with other parts where we try to get into other more facilities and more interesting, more capabilities of Sagemaker. So let me go and delete, because for now, if we don't delete some of these things, you would be running into costs. And one of the first things to do is to now make sure we stop our Jupyter notebook, the notebook instance. So let us go back here to our notebook, go to notebook instance, come here, action, stop. So it will take some time before we can delete it. Now we should be able to come here, look at our endpoints. So there's no endpoint here. We go to endpoint configurations, make sure that we delete this endpoint configuration, delete, make sure. So this is models. So we click here, action, delete, make sure you do that. So these are your packages. It's okay. Compilation job, yes, it's okay. Now let's we go back here to our S3 bucket. Go to S3. Remember to delete these resources so that it doesn't consume, but then I'll tell you the cost is very minimal. All this, the cost is very minimal. So here we are going to go now to our S3. So we are going to empty it. So we can say we should type permanently, so no objects found in bucket land price app. So let me go back here. Let me go here. So okay, so let's go back. Let's make sure that everything is gone, because we should make sure. So we've seen that it's empty. So now let's delete it. So let us delete it by confirming, by typing the land price app. So we have to type land price app, delete. Good. So now we know we've cleaned up everything, and we're not going to incur any costs after this. So I hope you enjoyed this, and I hope to see you next time. Thank you. Just don't forget to, the GitHub will be there, the links are there. You can always go there, take the GitHub and continue your training. Okay, thank you. See you next time.